Okay, so working here, 9, 10, 11, 12 are the same, except now we have a variable. So the setup for the 2 square root 3 is just the same as the earlier problems we saw in 5, like in problem 5. So 63, I would just do 3 and 21, and then that's 3 and 7. So I would have 2 square root of 3 squared times 7. Now, x to the fourth, if we think about our exponent rules, x to the fourth is the same thing as x squared times x squared, like that. And so what I can do is I can write it, so I can break this x to the fourth into x squared times x squared. And so then what I can do is this, so I'm actually going to kind of continue this down here. This 2, the square root of 3 squared is 3. The square root of x squared, so the 3 squared comes out, the x squared comes out, and the other x squared comes out. So that the square root of x squared becomes x. And the square root of my second x squared also becomes x. And the only thing left inside is the 7. Now when I combine it, you need to be really careful. 2 times 3 is 6. X times x is x squared, square root 7, like that. And 10, 11, 12 are all going to work the same. 10 is just n squared, so that's nice. So what we would have is 128, and you just do prime factorization, and that's 64. And then 64 as a shortcut is just 8 times 8. That's kind of a shortcut you can do. And so I would have 7 times the square root of 8 squared times 2 times n squared. I don't need to break this apart at all. My 8 squared comes out and my n squared comes out. All right. For problem 11, over here, 11, all right, we would do same thing, 48, prime factorization, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So I have 1 pair, 2 pairs. And so this is going to be minus 5 square root of 2 squared times 2 squared times 3. Now with p to the third power, I can just split that in p to the squared times p, because there's this imaginary 1. And remember, with my exponent rules, p squared times p is just p to the third power. And then what comes out is the 2 squared comes out, the 2 squared comes out, and the p squared comes out. And what I'm left with inside is just a 3p. And then I kind of combine everything else here. And 12 is the exact same as 11, 72, 236. 36 is just 6 times 6. To kind of make things simpler. So I'd have 6 square root 6 squared times 2. And then it's r squared r, because I can split it into 2, r squared and r. The 6 squared comes out, the r squared comes out. Now with these, both of these, you need to be really careful. I might, if you're getting a lot of wrong answers, so for example, this 3p for problem 11, I would write 3p, highlight it in Classkick, and then hit the square root button, and it'll actually give you the 3p around it. Same thing here, we're going to be left with 2r. Highlight the 2r, hit that square root button, and then it'll show you 2r square root, and then you can just kind of click over and add whatever needs to go in front of the square root. So that'll help you get to the correct answer.